Good morning students. Today start variation of electronic configuration of groups. All the elements present in 4 blocks. What are the 4 blocks means S, P, D, E, F. So group number 1 and 2 are called S block elements. Called S block elements. Group number 1 is called alkyl metals. Group number 2 is called alkaline earth metals. Alkaline earth metals. These are metals also soft and low boiling point. Low boiling point. Low melting point. Low ionization enthalpy. Highly reactive and form ionic compounds and color to the flame. Next group number 13 to 18. Group number 13 to 18 is called B block elements, otherwise called representative elements. Central electronic configuration NS2 NP1 to 6. NS2 NP1 to 6. The elements group number 16 is called chalcogens. Group number 17 is called halogens. Group number 18 completely filled orbital. Completely filled orbital means NS2 NP6. So this group is called inert gas or rare gas or noble gases. Group number 18 completely filled orbitals. S orbital also completely filled. P orbital also completely filled. So called inert gases or rare gases or noble gases. B block elements in characteristics: high negative electron gain enthalpy. High negative electron gain enthalpy. Second point, ionization energy higher than that of S block. Higher than that of S block elements. Last one, mostly covalent bonds only formed. Covalent compounds only formed. And more than one oxidation number present. More than one oxidation number present. Oxidation number or state present. Next, group number 3 to 12. Is called D block elements. D block elements, otherwise called transition elements. Transition elements. General electronic configurations NS 1 to 2, N minus 1, D 1 to 10. This is for general electronic configuration of D block elements, 1 mark side. 1 mark side. And also show more than one oxidation state. More than one oxidation state. And form co-ionic bonds, covalent bonds, and coordination bonds, compounds also formed. Coordination compounds also formed. They form interstitial compounds. Interstitial compounds. And allies. And allies. Last one, good conductor of heat and electricity. Heat and electricity. Next, F block elements. F block elements, otherwise called inner transition elements. Otherwise called inner transition elements. That what are the present means lanthanide and actinides. Lanthanide and actinides. General electronic configuration of lanthanide 4F 1 to 14 5D 0 to 1 6S 2. This is for lanthanide electronic configurations. Next, actinide electronic configuration 5F 0 to 14 60 0 to 2 7S2. This is for actinide electronic configuration. Also variable oxidation state also present. Variable oxidation state also present. Also present. Next, general outer electronic configuration of elements in groups. Group, general electronic configuration block. First, group number 1, general electronic configuration NS1. Group number 2, general electronic configuration NS2. So, 2 group is called S block elements. Group number 3. Group number 3, NS2 N minus 1 D 1. Next, group number 4, NS2 N minus 1 D 2. Group number 5, NS2 N minus 1 D 3. Group number 6, NS2 N minus 1 D 4. Group number 7, NS2 N minus 1 D 5. Next, 8, NS2 N minus 1 D 6. Group number 9, NS2 n minus 1 d7. Group number 10 n(2) n minus 1 d8. Group number 11 n(2) n minus 1 d10, not 9. Group number 12 general electronic configuration n(2) n minus 1 d10. So 3 to 12, 3 to 12 what block elements? D block elements. Next group number 13 ns2 np1. Group number 14 ns2 np2. Group number 15 ns2 np3. Group number 16 ns2 np4. Group number 17 ns2 np5. Group number 18 ns2 np6. Group number 13 to 18 is called which block? Means B block elements. And another one more block will be present, F block elements. F block elements divided by two types. First one lanthanide, another one actinide. That lanthanide electronic configuration 4F 1 to 14 5D 0 to 1 6s 2, that is called lanthanides. Another second one actinide 5F 1 0 to 14 5F 0 to 14 60 0 to 2 7s 2. This is called actinide. That is 18 group will be divided by 4 blocks S, P, D, F only. Next periodic trend in the properties. Periodic trend is the observed by physical and chemical behaviors of elements. The first one atomic radius. Second one ionic radius. Third one ionization energy. Fourth one electron gain enthalpy. Or electron affinity. Last one electronegativity. First one atomic radius. Atomic radius means distance between the center of its nucleus and then outermost cell containing the valence electron. The valence electron. Distance between the center of its nucleus and the outermost cell containing the valence electron. This is for nucleus. This is for electron. This is nucleus. The center of the nucleus and outermost consisting radius. Radius symbol R. That atomic radius, it is not possible to measure. So how will you measure? Means used covalent radius or metallic radius. It is not possible to measure. So go to covalent radius or metallic radius. Metallic radius will be measured except noble gases. Except noble gases. Covalent radius. It is one of the internuclear distance between two identical atoms linked together a single covalent bond. Covalent radius determined by X-ray diffractions. Covalent radius determined by X-ray diffractions. Go to the diagram. These were two identical atoms. Center nucleus. That nucleus distance that is symbol T. That radius, that is the radius, or it is the radius. Example, internuclear distance in chlorine molecule 1.98 angstrom. Calculate the covalent radius. Now see, distance between chlorine to chlorine equal to radius of chlorine plus radius of chlorine. The distance chlorine to chlorine equal to 2 radius of chlorine. So radius of chlorine equal to distance chlorine to chlorine divided by 2. So distance of chlorine to chlorine how much? 1.98 angstrom. So write 1.98 angstrom divided by 2. So answer 0.99 angstrom. That is radius of chlorine. You understand? Next, in case of heteronuclear atoms. In case of heteronuclear atom means how can calculated atom means how can calculate covalent radius. Simply method will be produced by Skopmaker and Stevenson. Proposed one formula. Distance of A, B equal to radius of A plus radius of B minus 0.09 into XA minus XB. XA, XB, what is mean by means electronegativity. XA, XB means electronegativity. Electronegativity. For example, Example, calculated covalent radius of hydrogens. Calculated covalent radius of hydrogen. Experimental value given. Distance of hydrogen chlorine equal to 1.28 angstrom. And chlorine also, previous sum. Radius of chlorine equal to 0.99 angstrom. Next, XA and XP electronegativity hydrogen. XCl equal to 3. X hydrogen equal to 2.1. That is given data. Now come to the formula. DHCl equal to radius of hydrogen plus radius of chlorine minus 0.09 into HCl bond X hydrogens. Now apply the value. Distance of hydrogen chloride 1.28 equal to radius of hydrogen find out. So radius of hydrogen right. Radius of chlorine 0.99 minus 0.09 into 3 minus 2.1. So 1.28 equal to radius of hydrogen plus 0.99 minus 0.09 minus means 0.9. 1.28 equal to radius of hydrogen plus 0.99 multiply means 0.09 multiply 0.09 means 0.081. 1.28 equal to radius of hydrogen plus that minus means 0.909. So next 1.28 into radius of hydrogen plus 0.09. So radius of hydrogen is equal to 1.28 minus 0.909 equal to 0.371 angstrom. That is the radius of hydrogens. That is which one? Covalent radius of hydrogen in heteronuclear atoms. Heteronuclear atoms calculated. Next, metallic radius. One of the distance between two adjacent metal atoms in the closely packed metal crystal is called metallic radius. For example, distance between the adjacent copper atoms in solid copper. How much means 2.56 angstrom. So metallic radius of copper equal to 2.56 divided by 2. So answer calculated 1.28 angstrom. Next, periodic trends in atomic radius. First one, variation of periods. Atomic radius means left to right. Going means along the period will be decreased. Decrease in atomic radius. Atomic radius decrease. Why decrease? Reasons. As we move left to right. The valence electron enters. Valence electron enter are added as same cell only. So atomic radius decrease, increasing the nuclear charge and as well as attractive force between valence electron of the nucleus. Atomic radius decrease along the period only. Next topic, shielding effect. Center dot is called nucleus. That first cell, this is one electron. That means what electron means? Inner electron. Inner electron. Here also electron is present. Here also electron is present. This is called outer electrons. This is called outer electron. That explain the shielding effect. The diagram only explain. The addition of electrostatical force between nucleus and electron. This is for nucleus. The addition of electrostatic force means here only added. Here only added. That will be attractive force. Attractive force. Attractive force. The repulsive force in inner cells and outermost cell of the valence electron become a degrees. Become a degrees. That why degrees means the inner cell electron. These are inner cell electrons shielded. That is here sealed. Here shielded. The outer cell electron will be free. So is called shielding effect. Shielding effect. Understand or not? One more time explain. Inner cell electron act as a shielding. Inner cell electron act as a shielding. That line is the shielded. The valence electron means the outer electron. Attractive force will be decreases. So this effect is called shielding effect. Next topic, effective nuclear charge. Effective nuclear charge. Net nuclear charge explained valence electron in the outermost cell is called effective nuclear charge. So mention the equation E effective equal to Z minus S. E effective equal to Z minus S. That Z is called atomic number. Atomic number. S is called screening constant. Screening constant. That we calculated used Slater rules. Calculated used Slater rule. Slater rule step 1. Step 1. Write the electronic configuration of the element. Write the electronic configuration of the element and rearrange them ns and np orbitals and others also. For example, 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p. So arranged means this is first near to nucleus 1s. This is second 2s and 2p. Next 3s and 3p. 3d will be separated. 4s and 4p. 4d separated and 4f also separated. 5s and 5p. That is electronic configuration written. Rearrange the n. N means a number. ns and np orbitals and others. Others means the d orbital and the f orbitals. Next, step 2. Identify the group. Identify the group. That means electron interest is present. Electron interest is present. That means group does not contributed shielding effect. Group does not contributed shielding effect. Does not contributed shielding effect. For example, denoted by En. Denoted by En. Simple is the En. That is shielded means extent 0.35 nuclear charge and 0.30 for unit 1s electron. 0.35 unit of nuclear charge. Nuclear charge 0.30 1s electron. Step 3. Shielding in inner orbital. Shielding in inner shell electrons. That belongs to s and p orbitals. S and p orbital. First one, each electron within a n-1 group sealed. -1 group sealed. Extent, how much charge means 0.85 nuclear charge. Second term, each electron within a n-2 and even lesser group also n-3, n-4, etc. n-3, n-4, etc.